In this problem, we are asked to find the estimate of the firm's total standard deviation given line residual standard deviation and R squared. So using Microsoft Word's equation creator, I've written equations that help solve this problem. So we start here by showing just the general definition of R squared. And this is that is 1 minus the residual variance divided by the total variance. And we can rewrite this as R squared equals 1 minus the residual standard deviation squared divided by the total standard deviation squared. Again, that just relies on the fact that variance is equal to standard deviation squared. Moving down to the third equation, this is just simply rearranging terms. It's bringing the R squared to the right side, so we have 1 minus R squared, and then the rest of the terms to the left side so that they are positive, and that so we can work with them moving forward. Moving into the fourth line, again, this is just rearranging. This is multiplying both sides by total standard deviation squared. And finally, rearranging one more time, we isolate total standard deviation squared by dividing both sides by 1 minus R squared. When we use this equation, it's very important to note that we have total standard deviation squared on the right side, so we must take the square root in order to find total standard deviation on its own. And in calculating this, I set up an Excel sheet which has a couple of verification methods in here. So as you can see, these are all if statements, and then these are all also verification, but then it's incorporating these equations so that when we plug in the residual standard deviation of 22.28 as given, and the R squared of 43.81%, then we get the output of a total standard deviation of 29.72%. And this is the correct answer to this. Again, these Excel equations just flow directly from these equations and the general definition of what R squared is and rearranging terms. All of these boxes down here are simply to check, and these are to make sure that these match and that this is a correct answer to this question.